So tonight we are talking about automotive HVAC update for 2016. So what are we going to do tonight? We're going to start out, we'd like to talk about some of the new SAE-J standards that have come out regarding the refrigerant change from 134A to 1234YF, as well as some of the standards that apply to 134A vehicles. We'll be talking a little bit about the process of handling 1234YF as opposed to our 134A. There are some slight differences. We're going to talk a lot about leak detection, different ways to do leak detection, including some new technologies in dealing with leak detection. We will be talking about how the changes that we are making from 1234 or from 134A to 1234YF, as well as some of the changes to the systems impact service and repair, and some new techniques for diagnostic to diagnosis systems. What we are hoping that you guys will learn tonight, we're going to talk about some of the updated tools. You can see we'll get into these. I don't think we're going to get into most of these tonight. I think most of these will be Thursday night. New ways to do temperature testing, ways to do pressure testing, some of the challenges that we are seeing with newer vehicles and because of the new equipment. But the key takeaway is that all of the techniques and everything that we are talking about tonight is just going to build on what we are doing from previous classes. We're not erasing things that we've been teaching for years. We're trying to build on them. So let's start with talking about the standards and some of why we are here. So the impetus in the United States to transition from 134A to 1234YF is part of the EPA's push for reduction in CO2 emissions. When the EPA does fuel economy testing, it's not so much that we are looking at the total fuel economy, the amount of fuel that the vehicle burns. We're looking at the grams per mile of CO2 emissions. So in 2016, the EPA pushed forward rules to eventually get below 250 grams per mile of CO2 emissions from vehicles. Some of the ways that the manufacturers can do that is, in addition to physically making the vehicles more fuel efficient, there are credits that are available to the manufacturers for doing certain things. One of those things is using a low global warming potential refrigerant. And we'll talk about what global warming potential is and what a low global warming potential refrigerant is here in a few slides, as well as some things to make the system tighter. Using 2 O-rings in a fitting versus 1, using 3 O-rings in a fitting versus 2 is a way to get credits. Making the air conditioning system more efficient using an inline heat exchanger, which we'll talk about. Doing some things like making the vehicle go into automatic recirculation over 75 degrees ambient temperature is a way to gain some CO2 credits. Originally, there was going to be a phase out of R134A in new production vehicles for 2021 model year. That phase out originated in Europe, and part of the push for a low global warming potential refrigerant came out of Europe. European Union regulations pushed for a low GWP refrigerant starting for 2012 model year for new platforms and across the board for 2017 model year. In addition to that, Europe also started cutting back on the allowable imports of R134A, which is something we have not done in the United States. As it stands, that phase out is not currently happening. There was a lawsuit in 2017 by manufacturers of refrigerant. Currently, the only 2 companies that manufacture R1234YF for automotive use are Honeywell and DuPont. Honeywell holds the patent on 1234YF for automotive use and licenses that patent to DuPont because Chemours now is the name they're operating under, because Chemours did the research with them. Other manufacturers that make R134A that do not hold the patent to make are 1234YF for automotive use, sued the EPA. They stated that the EPA overstepped their authority, that the Clean Air Act gave the EPA the authority to regulate greenhouse gas emissions, or excuse me, ozone depleting refrigerants. It did not give them the authority to regulate refrigerants with high global warming potential. They won. The rule was sent back. It has been appealed. The EPA was supposed to issue a new rule earlier this year. As far as I know, it has not been issued yet. That said, it is very unlikely that manufacturers are going to go back to R134A at this point in time. It is likely that we will still see the transition to R1234YF happen and continue to happen. So when we talk about global warming potential, what is global warming potential? And what is an ozone depletion? So if we go back to when this transition was occurring from R12 to R134A, think back to the mid to late 80s. The mid to late 80s was a very bad time for the environment. We had a hole in the ozone layer. And it was found that when CFCs, which R12 is a CFC, chlorofluorocarbon, when CFCs were reaching the atmosphere, the chlorine molecule was breaking off as the molecule broke down, and it was breaking apart the ozone layer. What the ozone layer is part of the Earth's atmosphere that starts to protect us from ultraviolet radiation from the sun. We had the hole in the ozone layer of the southern hemisphere, and something had to be done. The Clean Air Act was passed in 1990. Part of the Clean Air Act gave the EPA the authority to regulate ozone depletants, and we started phasing out ozone depleting refrigerants. We replaced, for automotive use, R12 with R134A. R134A is a much more environmentally friendly refrigerant. That said, there was still room for improvement. R134A has a high global warming potential. A GWP of 1430. What global warming potential means is, with CO2 as the baseline, CO2 has a GWP of 1 when a refrigerant that has a GWP of 1430 means that it is 1430 times more likely to contribute to global warming than CO2. CO2 is the baseline of 1. So you can see from this chart, we moved from a refrigerant that was 10,900 times more likely to contribute to global warming to a refrigerant that was 1430 times more likely. That's a big step. What's considered a high global warming potential refrigerant is a refrigerant with a GWP over 150. So 134A was still 10 times too high. Refrigerants that came out as potential were HFC 152A, CO2, and 1234YF. 152A, while it meets the GWP requirement, has a GWP of 124, was ruled out because it is very highly flammable. 152A is commonly used as computer spray duster, and you can find videos on the internet of people basically lighting it on fire. It is flammable. Because of that, to use it in a car air conditioner, it has to be used in the secondary loop system. There is one vehicle manufacturer that is currently experimenting with it. There is nothing in production yet. CO2 was the direction GM initially thought they were going to go. They found that there is a big efficiency drop in warm weather compared to 134A when using CO2. and that the pressures are incredibly high. We're talking pressures 10 to 20 times the working pressures of 134A. 1234YF in original testing was found to have a global warming potential of 4. It currently, current research is found to have a GWP of less than 1. So it is less likely than CO2 to contribute to global climate change. As technicians, how it works for us, as far as when we're fixing a system, it works very similar to R134A. Similar performance, some slight changes to the systems to improve performance. The downside is it is mildly flammable. It is called an A2L refrigerant. That means that if you expose it to an ignition source, it will ignite, but it will not sustain a flame if that ignition source is taken away. Because it is slightly flammable, there are some changes to the systems for safety and some changes to the equipment for safety. So the question is it really safe? SAE did a lot of research on 1234YF to make sure that it was safe. The conclusions that the SAE came to, working with multiple vehicle manufacturers, was that yes, it is safe. The toxicology risks, the flammability risks are comparable to the current refrigerant at the time of 134A. Had the lowest life cycle emissions of all potential refrigerants, no significant environmental side effects, and that this was the way that most of the manufacturers decided to go. So the question is, how flammable is it? What this chart shows is the minimum ignition energy, basically how much energy you have to put into the substance in order for it to ignite, and what the lower flame limit is, meaning the lowest concentration of the substance in order for it to ignite. And if we look at this, here is 1234YF up in the top right corner of the chart. As we move from the top right to the lower left, flammability increases. So we're way up here. Look at something else that is very, very common under the hood of a car that is way down here. Gasoline. So it's really not something, the flammability when we're working with the refrigerant is definitely not something we really need to be concerned about. It is very, very hard to ignite. And if we look at how much energy it produces, combustion energy and burn velocity, so how much heat is produced by burning it versus how far fast it spreads, it's very, very close to 134A. I do have a video here that I would like to show.
Bandwidth on your end's been a little bit, it's been doable, but it's been a little bit questionable. So I'm curious if this is going to work for you. We'll see.
Let's see if this works then or not.
While you're getting that going, there is a question. Do you know when the heavy duty and off-road industry is going to move over to 1234YF?
When is the heavy duty and off-road industry going to move? It is not likely at the moment. One of the concerns with heavy duty and off-road industry is truly that the systems are completely different than what we currently have with a light vehicle system. Originally, when the regulations came about for 1234YF, the refrigerant was only originally approved for light vehicles. The EPA considers a light vehicle to least 600 pounds GVWR. So it was basically for cars and half-ton trucks. It was only in later revisions that they allowed it for 3/4 ton and up and into the medium duty. The reason for that is that basically think about, is there a whole lot of difference between the cab of a Ram 1500 and a Ram 3500? No, not really. So, but there is a lot of difference between the cab of a Ram 1500 and the sleeper cab of a heavy duty truck. So it's not likely, at least for the time being, that we're going to be seeing 1234YF in those vehicles. And as Bryn said, we're having some bandwidth problems on my end. This video will not play. I will make sure to have a link in the comments on ready for Thursday night. What this video is, it's a video from a testing lab in Australia, basically trying to ignite 1234YF. And it shows you're trying to ignite it and you really can't ignite it. The question of flammability in technician safety with 1234YF always inevitably leads to the question of the Mercedes experiment. Everyone's heard about this by now. Mercedes, back around 2012, I believe, set up an experiment. They took a B-class SUV. They designed an experiment to make 1234YF combust. They gave it the absolute perfect conditions to make 1234YF combust. And you can see these pictures of their underhood setup. So this is, as I said, a B-class SUV. I believe it is a diesel. I could be mistaken on that. But what we see here is we have the discharge line of the AC system coming off of the compressor. A tap off of that to a solenoid valve to release 1234YF at exactly the correct time. We've put a throttling valve in to completely control the amount of 1234YF for fine tuning. A copper pipe here that is a preheat pipe designed to preheat the refrigerant as it's working its way to this nozzle that was designed to perfectly atomize 1234YF. Then they did some things to the vehicle.
Some more things.
Yes, there's some more things. Here's some other pictures. But they took and they overrode the cooling fan control. So the cooling fan's not running at this point. Why that's important is if we had the cooling fan running, the air coming through the front of the car is going to start to disperse that refrigerant, which would normally happen in the conditions that they were using. They ran the vehicle up a 10% grade, wide open throttle, engine in critical overheat, repeatedly. Had that exhaust, we go back, you can see that nozzle is pointed right at an exhaust pipe and into an unheat shielded section of the exhaust pipe. So we had exhaust temperature over 800 degrees centigrade at this point in time. Red hot exhaust with an undercharge. So we had less than half of the refrigerant in the system. And on the 5th attempt, it lit up. So we completely designed an experiment, gave it every chance in the world to make it ignite. And it ignited after 5 attempts. Now, let me ask you a question, Bryn. Is this a real world condition?
It was for them at that point. No, absolutely not. No.
Right. So one of the questions that I get asked a lot when I'm teaching like a 609 class I usually wind up with some guys in the shop that in the class that run tow trucks, and they'll ask, what do we have to do to make sure after this vehicle's been in an accident that we're not going to have a problem with refrigerant being released, or that is released catching fire? One of the things that I like to say is if you look up on the safety data sheet, the auto ignition temperature is for 1234YF, and what the auto ignition temperature is for ethylene glycol, antifreeze. Antifreeze has a lower auto ignition temperature than 1234YF. So basically, if the antifreeze isn't on fire, the refrigerant's not going to catch fire either. So now let's talk about some of the standards that are in place. Anytime we have a major change in the auto industry, we have to have some standards to regulate it and to govern it. Those standards that...
Sorry to interrupt. Yeah. I know that was a Mercedes, but wasn't it Mercedes behind that experiment?
Yes, it was Mercedes behind that experiment. This was Mercedes in-house experiment. Good question, Rich. This was one Mercedes did. They had it. They were convinced that 1234YF was bad. They wanted to go the direction of CO2. This was their experiment to say that 1234YF was bad. And it was after this experiment, if you remember in 2012, 2013, Mercedes made a big deal about it here in the United States. They had released vehicles into the United States that were 1234YF. They took those 1234YF vehicles that were released, recalled every one of them, and turned them into 134A vehicles.
Don't some speculate that it was a matter of demand, their ability, to be able to transition their whole brand, their whole fleet over to 1234YF?
There's a lot that was going on in the background of it. The background
is on a tangent.
Very interesting. Yeah, that's something. It is very curious. It is a topic that I don't want to go into tonight.
Yeah.
I think it tends to lead into some tangents, and there's a lot of background to it. So
Yeah.
we could sit here and talk for the rest of our time tonight about Mercedes experiment, but I don't think our students want to do that. So the standards that are relevant to 1234YF, J2913, that is the standard for electronic leak detectors. J639 is one of the standards for air conditioning systems that governs the label, and it governs things like service ports, things like that. So we do have new underhood labeling. 2842 is a standard for evaporator design. We'll talk about that as we get to it. There are some changes with 1234YF evaporator cores. 2912 is standard for refrigerant identification. This is very important. Refrigerant identification is no longer optional when we're dealing with 1234YF. J2970 is a standard for forming gas. Forming gas is a method of leak detection that can be used for 134A or 1234YF. J2911 is a standard that allows an audit of whether something actually meets the SAE standard it's claiming. And 2845 is an update to the training curriculums to include information on 1234YF. So 2911 allows for verification of whether something actually meets the standard it claims or not. The way that you can find information about whether pieces of equipment, tools, training courses, or what have you actually meet the standard that they're claiming is through a website that SAE maintains. It's called the MAC Manufacturer Database. The website is macdb.sae.org. I'm going to change the screen here and actually pull up the MAC database. So if you go to macdb.sae.org, this is what you see. And the way it works, if I have a particular criteria that I want to search on, like a piece of equipment, a tool name, something like that, I can put it into the box, search it. If I want to see everything that meets a particular standard, I can do that too. So let's pick here J2788. That's the standard that governs an R134A refrigerant recover and recycle and recharge machine. You'll see there are two versions of the standard listed. We have J2788 2013-01. That means that's a version of the standard that was published in January of 2013, and now a new version that was published in January of 2020. So if I select these two standards, say, I'm looking at buying an R134A recovery machine, and I click search, and I will see every piece of equipment that meets one of those standards. We can see what standard that piece of equipment is certified to, name and part number, as well as when that piece of equipment was certified and when the certification expires. So you see all of that for a R134A recovery, recycle, and recharge machine. So again, that is a very helpful tool if you are looking to buy a piece of equipment, looking to buy something to see, does it meet the standard that the manufacturer claims that it meets. J2843 is our machine standard. Any recovery, recycle, recharge machine that is used with 1234YF has to meet the standard. There are some changes to these machines versus R134A machines. There's a lot of talk of floating around on the internet of, can I convert an old 134A machine to a 1234YF machine? And the answer is you really shouldn't. Because the refrigerant is mildly flammable, some of the changes to the physical machine are that we've made all of the components inside, motors, switches, solenoids, things like that, anti-arcing. So that if there is any buildup of 1234YF in the case, should the machine start leaking, it will not ignite. In order to prevent a buildup of 1234YF should the machine leak, there is improved case ventilation, fans moving more volume of air through the case so that any refrigerant that does leak from the machine does not build up and cause the potential for fire hazard. As I said earlier, identification is no longer optional when we are dealing with 1234YF. Since the beginning of the R134A days, we've been recommending that every vehicle that comes in for air conditioning service that you're going to deal with the refrigeration circuit should be identified. We're looking for what refrigerant is in it. We're also looking for things like, do we have air contamination, things that could lead to possible system performance problems. With 1234YF, that is no longer an option. It is mandatory. Either the recovery, recycle, recharge machine has to have an identifier built in, or if you do not have a built-in identifier, you have to use an external identifier tethered to the machine with a USB cable, and the machine will not allow a recharge or refrigerant to be recovered unless it receives a 128-bit encrypted signal from the refrigerant identifier saying the refrigerant is pure. There are very few people, if you're trying to get around this, there are very few people on the face of the earth that know what that encrypted message looks like. You're not going to get it out of them. There is no way around identifying with a 1234YF machine. There are also some menu changes, things like we're picking if the machine is, or if we're working on a hybrid or a non-hybrid vehicle. Before we recharge, the machine is going to require you to do a gross vacuum decay leak test, and you're also going to do an evaporator leak test. And we'll talk about some more as we go along here as we get into leak detection. So the performance of these machines, the performance of the machine for 1234YF is very, very similar to the standard for 134A, the J2788 standard. What that means is we have to recover 95% of the refrigerant in the system within a half of an hour. When we recharge, the charge has to be accurate within a half of an ounce. Now, half of an ounce to an ounce doesn't seem like a lot, but think about this. How much tighter are we making AC systems today? How much smaller in capacity? I mean, Bryn, what's the smallest AC system that you've seen in your shop off the top of your head?
Maybe like 12 ounces.
Yep, that's the smallest one that I've seen as well. So if we're thinking about that, a 12-ounce system, what's 1 ounce of refrigerant to a 12-ounce system? That's a 9% charge difference. What's 1 ounce of refrigerant to my Suburban that holds 3 pounds of refrigerant? Nothing. So as we're making the systems tighter and tighter, our charge accuracy has to be better. And there are a couple of ways that the manufacturers are doing this with the equipment. One is the scales are better. The scales also, you can see it sitting in the tray of the machine here. It came with a calibration weight so that we can periodically check the accuracy of the scale that is inside this machine. Set the calibration weight, it is a known weight, and look at the weight increase on the display to see if our scale is accurate. When we are charging the refrigerant, you always would have some refrigerant left inside the machine. There's in the internal plumbing, in the hoses. There's two ways that the manufacturers can compensate for that. Either charge compensation, where the manufacturer says, we know that this machine and this set of hoses holds XY amount of refrigerant. So when we charge the system, we are going to add that much extra refrigerant to compensate for how much is left inside the machine. The other possible way to charge is using hose compensation, where after we finish charging the vehicle, we then close the high side service coupling, open the low side coupling, and allow all of the refrigerant that's in the high side hose and in the internal plumbing in the machine to be pulled into the vehicle through the low side. These machines will also lock you out if the filter is not changed periodically. The filter change is required every 150 pounds of refrigerant. So because we have to change a filter every 150 pounds, and the machine will lock if we do not change the filter as required, we really need to look at some ways that we can do charge verification testing without just recovering the refrigerant from the system. That was one of the things, if you thought a vehicle was undercharged, recover it, see how much refrigerant is there. But we might want to take a step back and look at some ways that we can verify whether our charge is accurate without doing that. And we'll look at those in the second part of the class. As I said, refrigerant identification is mandatory. One piece of advice that I will give you, I highly recommend, in addition to having the identifier built into your machine, I recommend having a standalone identifier as well. The reason being is when a car comes in, the first thing that I like to do is identify it. Because if the refrigerant is contaminated, I want to know about that before I sell any type of repair to the vehicle, because now I've got refrigerant that I have to dispose of, rather than wait until we're going to recover to identify the refrigerant. I would also recommend that when you do purchase a machine, you purchase a machine with a built-in identifier. My machine does not have the built-in internal identifier. I have to connect an external identifier, and it can be a bit of a challenge sometimes to get it synchronized correctly, so that everything talks. As I mentioned, there are leak tests required. After the system is evacuated, before you go to charge the system, you will do a gross vacuum decay leak test. So we'll pull the vacuum, and the machine will sit there and watch for a period of time and see if the vacuum level in the system decays. If it decays past a certain point, we fail the vacuum decay leak test and we will not be allowed to charge. That said, while you will not be allowed to put a full charge of refrigerant in the vehicle, you are allowed to put a partial charge in the vehicle of 15%. Whether you pass the vacuum decay leak test or not, you'll be putting 15% of the refrigerant charge in as a next step to do a leak test. If you failed the vacuum decay leak test, now you've got 15% of the charge to the system to go find your leak. If you pass the vacuum decay leak test, you have 15% of the refrigerant in the system, and you're prompted to go do a gross evaporator leak test. So to run the vehicle, air conditioning off, lower motor on low speed, take an electronic leak detector that meets the standard for 1234YF, put it in the center floor duct for 15 minutes, and see if it triggers, if we have a leak test of the evaporator or a leak in the evaporator core. The reason for this is that, as we said, this refrigerant is mildly flammable. So we do not want to run the risk of having a mildly flammable substance released into the passenger compartment. Some machines will sit there and count for 15 minutes as you're doing the evaporator leak test, some do not. The machine may also prompt you, does this vehicle have a second evaporator core? Does it have a rear evaporator? If it has a rear evaporator, then we have to go do the same test on the rear evaporator. If we failed the evaporator leak test or we failed the gross vacuum decay leak test, then we would recover the 15% of the charge and go fix the car. If we pass both leak tests, you will be allowed to fully charge the vehicle. Some slight differences between machines. Many of the machines have just the internal tank. Some machines, like this Robin Air machine, have onboard storage for a virgin tank of refrigerant. What's nice about this machine is you can set the level of refrigerant that you want in the onboard tank, and rather than having to remember to refill the machine will do it for you. Once you get to a certain level, it will refill the internal tank from the onboard virgin tank.
When you were talking about evaporator leak testing, you were saying, kind of giving bullet points of each step. I imagine not all machines, but the machines that you've used laid out those steps in the walkthrough?
Yes, I can speak for both of the machines that I have used. After you evacuate the machine or the system, the machine makes you pause and do the evaporator leak test or do the vacuum decay leak test. And then it prompts you to go step by step through the evaporator leak tests. So it's not something that you as a tech have to remember, oh, I've got to do this. The machine physically isn't going to let you proceed without doing it. And it does have these step-by-step menus for how to do it, at least the ones that I have used. Now, there is a second standard for refrigerant recover and recycle equipment for 1234YF. In addition to J2843, which is a machine solely for 1234YF, we have a standard that is called J3030. These are dual machines. Now, what do I mean by dual machine? That means that these are machines that are capable of recovery, recycling, and recharging both 134A and 1234YF. There are currently 3 different versions of J3030 machine on the market. The one that's pictured here, the CPS FX3030, is what we call a back and forth machine. So you can see how this machine is laid out. On the back of the machine, we have the refrigerant cylinder on a scale with the filters attached to it and hoses that go up into the machine. On the front of the machine where the hoses attach, the service hoses attach, they attach into kind of a manifold that slides into the front of the machine. So if I have the machine set up for 134A and a 1234YF car comes into the shop, what I'd have to do is start a process to change the machine from a 134A machine to a 1234YF machine. And what I would do, I would initiate the process through the machine's controls. The machine is going to evacuate all of the refrigerant into the tank and purge the internal plumbing. We would then open the back of the machine, remove the 134A tank and filter and hoses. From the front of the machine, remove the service hoses and swap in for the 1234YF tank and hoses. At which point, finish the process. Now I've got a 1234YF machine sitting in front of me. I finish that car, I can go back to an R134A machine. So this is a machine that's like this, a J3030 machine, where you can go back and forth, is a great tool for the shop that is not doing much 1234YF. You know, you can buy a 3030 machine today. It can make you money today as a 134A machine. And then when the car that comes in that needs 1234YF, you have a piece of equipment that can handle it. Eventually, if your 1234YF business grows, you decide, okay, I'm going to leave this machine as 1234YF and buy another 134A machine, or I'm going to leave this machine as 134A and buy another 1234YF machine. The other versions that are on the market is a machine by Yellow Jacket, Ritchie Engineering, that is a J3030 machine, but it is only one-time changeover. That means that I buy the machine today, it's a 134A machine. At some point in the future, I decide that I want it to be a 1234YF machine. I change it over to 1234YF, but once it's a 1234YF machine, it's a 1234YF machine. I can't go back and forth. The third interpretation is the machine that Snap-on sells, that it's basically two machines bolted together in the same cabinet. There's no changeover because there physically is no internal plumbing share. It's physically two AC machines bolted together. The downside to that machine versus this machine is that machine is really, really, really big because it's basically two machines bolted together. As I said, some of the menu changes, you're prompted if is the vehicle a hybrid or standard system. Part of the reason for that is when we're dealing with high voltage vehicles with sealed electric compressors, we have the issue of oil contamination. We need to make sure that none of the PAG oil from a standard vehicle makes its way into that high voltage system. Vehicles with high voltage electric compressors use a special PO oil that has dielectric properties to insulate the motor windings from the compressor case, and we don't want to run the risk of dielectric breakdown. So when we start a hybrid cycle, you're prompted to make sure that the hoses are connected to ports on the back of the machine, like there, and the machine will do a hose flushing process to make sure that there's nothing left in the hoses or the internal plumbing of the machine from the last vehicle to make sure that everything is clean and ready to go with a hybrid. As we said, we have some standards for refrigerant identifiers. J2912 is for a standalone handheld identifier. J2927 is for the refrigerant identifiers that are built in to the R machines. Now, one thing to note on the identifiers for the R machines, you don't see this a whole lot because it's under the cover on a lot of the machines, but just like a handheld standalone identifier, we have a filter. This filter periodically needs to be changed. When the outside of the filter element starts to turn colors, that means that it has been exposed to moisture or oil and it needs to be replaced. That filter is a line of defense on your refrigerant identifier. I speak from experience on this because I lost a refrigerant identifier to oil. I had a vehicle that had a significant oil recharge. When I went to identify, I hooked up my low side coupler, wasn't really paying a whole lot of attention. In less than 5 seconds, all of that oil blew out, blew past the filter into the gas bench, and there went my refrigerant identifier. So pay attention to the filter, pay attention to the hoses to make sure you don't have oil in your sample hoses. If you do have oil in the sample hoses, it's best practice to replace them. Now, there is another standard that we haven't talked about yet. That is J2851. Now, one of the things that we said with mandatory identifiers, we can't recover contaminated refrigerant into these machines. There physically isn't a way to do it. So we have to have another way to remove contaminated refrigerant from the vehicle. We can't just vent it. It's not lawful for us to vent it. So 2851 standard is for a recovery-only machine to recover contaminated refrigerant from a 134A or 1234YF system so that it can be disposed of properly. Keyword properly. If you get into a vehicle that is contaminated and you have to dispose of contaminated refrigerant, it can be very, very expensive to dispose of. I've heard of prices anywhere between $50 and $100 a pound. So make sure if you get into that situation that the customer knows, because in the end, ultimately, the customer is going to have to pay to get that refrigerant disposed of. So we have some changes to the evaporator core with a 1234 YF vehicle. SAE J2842 is standard that governs evaporator cores. I see that Peter Cole is raising his hand. I assume Peter has a question.
Peter, you got a question? No.
No.
Let's see. Attendees, everybody, Tim, usually instructors will ask you to raise their hand if you guys are following along, okay, or if you have any questions. Now it looks like he said, oops, yep.
Okay, not a problem. So the J2842 standard is the standard for evaporator cores in service. Any vehicle that is 1234YF has to have a J2842 evaporator core. So if you're replacing an evaporator core in a 1234YF vehicle, because let's be honest, yeah, Chrysler still makes evaporator cores. They do still fail. You have to make sure that the core that you put back in the box at least meets the J2842 standard. If it is an original equipment evaporator core, it meets the standard. The OEMs are allowed, there's a self-certification process that they can certify their own evaporator cores. If it is not an OEM evaporator core, it will actually have a sticker on it that says it is certified to J2842. Some OEM cores have the J2842 sticker, some do not have the 2842 sticker. You may not install a used evaporator core into a 1234YF vehicle. Now, there is some confusion over this. It's not saying that standard is not saying that if we take the evaporator core out of a vehicle for some type of service, say I'm pulling the HVAC box to replace a heater core, I am allowed to put that evaporator core back into the vehicle that I took it out of. I am not allowed to take that evaporator core and put it back into another vehicle. So basically, if I've got a problem, I call down to the salvage yard for an HVAC box, say, and that HVAC box comes with an evaporator core in it for a 1234YF car. I may not install that evaporator core into another vehicle. The biggest thing with this standard is that we are improving materials in the evaporator cores. We are making them more corrosion resistant, and we are reducing the chance of leaks. There's better coatings, trying to do what we can to minimize the potential for leaks. Again, we are dealing with a mildly flammable refrigerant, So we want to minimize the risk of a potentially flammable substance being released into the passenger compartment. Because we are requiring that the evaporator core meet this standard, this is one of the reasons why there is no retrofitting from 134A to 1234YF. You know, you may have a vehicle that is a 134A vehicle that is a relatively new 134A vehicle that is sold as a 1234YF vehicle in other parts of the world. That probably has a 2842 evaporator in it and would most likely be safe to have 1234YF in it. I can guarantee you my 2002 Suburban does not have a 2842 evaporator core in it, so it would not be safe to put 1234YF into that vehicle. Conversely, going back to one of the things I said at the beginning, that the manufacturers are receiving CO2 credits for using this low global warming potential refrigerant. Because the manufacturers are receiving a credit for it, it is considered emissions tampering if we take that 1234YF out and charge 134A or another refrigerant into the system. In the eyes of the EPA, replacing a low global warming with another refrigerant is the same as taking a catalytic converter off the car. It is tampering. The fine, if you are caught doing it, is somewhere north of $44,000 per occurrence. So you definitely want to make sure that you're putting the right refrigerant into a 1234YF vehicle. And because we have mandatory refrigerant identification on a 1234YF vehicle with our RRR equipment, if you put 134A into it, the next person that services that vehicle is going to know that someone put 134A in it. So the changes in the labeling. This label,
Basically,
this version of the label.
You just said that they could run, but they can't hide, basically, right?
Basically, yeah, you can run, but you can't hide. Your hope would be if you put 134A in that vehicle, that till the next time it was serviced, it changed hands and it couldn't come back to you. Again, why you would want to put 134A in a 1234YF car is beyond me, but that's, you know, there are guys out there that are doing it. In the last 2 years, I've had 6 cars come through the shop that had 134A in them that were 1234YF cars. So people are doing it. This is what the current version of the J639 label is. There are some things that have been added to it. One, you see the label that the system should only be serviced by qualified personnel. That's been there for a while. We added a picture logo. You can see the little guy in the upper right-hand corner, that's the mechanic with the wrench, has a little badge on his chest. That means we have certified qualified personnel. In addition, we're calling out the J2845 standard on the label, which is technician training. We have a notice that we have a mildly flammable refrigerant, hence the fire. We're told our charge capacity and what refrigerant oil. Now, this is a Toyota label. Toyota is nice enough to tell us on the label exactly what oil goes in the vehicle. Some manufacturers just say PAG oil, and you have to go to the service manual and try to figure out what the correct oil is. Toyota is nice enough here to tell us that this vehicle gets ND11 as its oil. Refrigerant type 1234YF, 470 grams plus or minus 30. So we have a charge specification and a tolerance. It's a Toyota vehicle. We're claiming that this vehicle system complies to J639, and also that we have a 2842 evaporator core installed. This is Chrysler's version of the label. You can see some of the same things. Qualified personnel, mildly flammable refrigerant, what refrigerant, the capacities, the oil. One thing to pay attention to on a label like this is the charge capacities. So we see this particular vehicle, this is probably a Challenger, if I was going to guess, a Challenger or a Charger. We have 5 different engine options. 3 of the 5 get the same charge spec. The 2 different versions of the 6.2 each have a different charge spec, and it is different from the other 3. So what's going to happen, Brent, if we take that 6.2 and charge it to the 6.4 spec. So instead of putting 1.38 pounds of refrigerant in it, we put 1.56 pounds of refrigerant in it.
It's not going to perform right. The pressures are going to be off.
Yep, we've got an overcharge. We've got close to a 10%, maybe a little over a 10% charge difference. Conversely, if we take that 6.4 and charge it to 6.2 spec, it's not going to cool. We've got a system that's undercharged. And in addition to the system just not cooling because it's undercharged, we're also going to be starving the compressor for oil. So remember, we rely on refrigerant oil to circulate, or the refrigerant to circulate the oil through the system. We also rely on that cold refrigerant coming back to the compressor to cool the compressor case. Yeah, in some testing we did at Max, we saw a 20% undercharge on a vehicle, giving us over a 60-degree elevated compressor case temperature because we didn't have that cold refrigerant coming back to cool the compressor. The question we get a lot is dye needed? Do we need to add dye to the system when we service it? The answer for the most part is no. Check the labels and check the service information. Many vehicles being built today are being built with dye on the assembly line. You know, Ford started putting dye in their system somewhere around 1997 and has continued to present day. GM started in 2002 and puts on the label that the system contains dye. Chrysler has a service bulletin. They started putting dye in their vehicles on the assembly line in 2011. Volvo puts it on the label when they have dye in it. Nissan's nice enough, they make their labels green if the system has dye in it to tell you it's got dye. Currently, every manufacturer with the exception of Toyota is installing dye on the assembly line. Dye is one of those things where too much is as bad as not enough. Just think about what leak detection dye is. It's a fluorophore, what fluoresces, what glows, mixed with oil. So let's say we put, I don't know, my dye injector holds a half an ounce of dye. Let's say I decide I'm going to put a half an ounce of dye in every vehicle that comes in for service. Many modern systems, because we're trying to minimize the amount of oil and we're trying to minimize how much oil circulates through the system for better performance by keeping that oil in the compressor with an oil separator, hold less than 3 ounces. So again, if I just go and put a half an ounce of dye into that system, that could be a 15 to 20% overcharge of oil in the system just because I put dye in. So make sure that if you are going to add dye, that you're not adding dye to a system that already has dye in it that does, you know, an extra dose isn't necessarily helpful. And make sure that you are adding it following the manufacturer's instructions. If you are using dye, make sure that your dye meets the SAE standard. The SAE standard for dye is J2297. So make sure that you're using a good quality dye that meets this standard. Make sure that you're using a dye that is OEM approved. And make sure that you are using the right dye for the vehicle. Yes, there are different kinds of dyes out there. Dye that is compatible with 1234YF is going to have a different carrier oil than dye that is only compatible with 134A. PAG oil that's used with 1234YF has some extra additives in it that a 134A PAG oil does not have, though that 1234YF PAG oil is backwards compatible and can be used in a 134A system. So this 1234YF dye is okay to use in a 134A car. That said, if you're going to put it into a hybrid, make sure that you're using a dye that is hybrid safe. There are a few of them on the market. That's going to have a different carrier oil and a different fluorophore to make sure that we're not interfering with the high voltage insulation. Electronic leak detectors. Most guys have a love-hate relationship with electronic leak detectors. And we'll talk in the second part of the class more about electronic leak detection. Two standards for electronic leak detection, 2791 for 134A, 2913 for 1234YF. 2913 leak detector generally exceeds the 2791 standard. What we are looking for, the standard is that we can find a 4 gram per year refrigerant leak at a distance of 3/8 of an inch with the probe moving at a specified rate. So again, make sure that your leak detector meets these standards. These two leak detectors, one by TIFF and one by Robinair, are very similar detectors. However, the one on the red one, the Robinair one, is approved for 34YF. The blue one is only approved for 134A. That said, if you're looking at buying an a leak detector, go back and look at the MAC database and make sure that the standard, that the piece of equipment that you're buying is still currently certified. I can tell you that these two detectors, the certification has expired on both of them. Neither of them are currently in production. Another example, notice the nice misprint on the handle of this identifier. There is no standard 27913. But again, make sure that your identifier meets the standards. Now, I mentioned forming gas. Bryn, have you heard about forming gas yet?
Yeah, I have. I don't have anything at our shop, but yeah, I've heard of it.
Yeah, I have not decided to invest in this technology yet. The standard for it is J2970. Basically, what we're doing is we're taking a piece of equipment, we're using a gas that is 95% nitrogen and 5% hydrogen, pressurizing the system with that, and then using a leak detector that is capable of detecting the hydrogen to do a leak test. I did check, forming gas is available from some gas supply houses. Air Gas has it available. My local Air Gas does not stock it, but they said if I wanted a bottle, I could get it in a couple of days. They claim 20 systems per bottle of forming gas can be detected. Ford currently is the only OEM that approves forming gas, and they only started approving it for 2020 model year. So if you look at, I spot checked most of the 2019 models, and none of the 2019 models that I looked in service information for talked about forming gas for leak detection. The only leak detection methods were detection with refrigerant or detection with dye. For 2020, the models that I looked at that I had complete service information for did call out forming gas for leak detection. The reason why forming gas and Ford has approved forming gas goes back to European regulations. In the United States, it is currently lawful to charge a system with a charge of refrigerant for leak detection. In Europe, it is not. So if we can't put refrigerant into the system to find a leak, we got to have another way to find a leak. So that's where this came from. You know, for years and years, guys have used nitrogen to find leaks. The problem with pressurizing with nitrogen is, again, detecting it when it leaks. Because this has the trace amount of hydrogen, we now have a detector that can detect the hydrogen. Techno Tools makes this kit, the kit that's pictured. I believe Robinair sells a kit as well. The thing that I don't like about forming gas personally is that, to me, this is like a resistance test. You know, when we're talking about drivability, we talk about dynamic testing versus static testing. And we always say that a resistance test is a static test because we have to open the circuit and we can't make it physically work while we're testing. You know, if I take an ohm meter and measure the resistance of a cam sensor, and it's supposed to be 400 to 700 ohms, and I measure 20,000 ohms, well, that cam sensor is bad. I think we'd all agree with that. If I measure 550 ohms, it might be good, but it might still be bad. To me, testing like this is the same way. If you look at the service information from Ford, when you're testing with forming gas, you only pressurize the system to 60 psi. So I could have a system that'll hold forming gas, but at that 60 psi and with the forming gas in the system, I can't make that system work hard. I might not be able to generate enough pressure to make a condenser leak. I might not be able to make that discharge hose leak. I think this is another tool in your arsenal that could come in handy. It is, again, goes back to there is no one way to find leaks.
So I guess the advantage here is if, of course, I guess the advantage is because 1234YF is so dang expensive, if you suspected a vehicle had a leak and you just really didn't want to, risk losing a lot of refrigerant in the process, I guess that's what the advantage is for you trying to use forming gas for leak detection. Yeah.
That's definitely a possible advantage for it. If we've got the system that's got the gross leak, it failed the gross leak test, and I need more pressure than I can get with 15% charge, or I don't want to lose 15% of the charge to a gross leak, then I think that's probably a very good place for this. But again, I'm not sure how well forming gas is going to work on trying to find that small leak. Yeah. I think we're probably going back to refrigerant, electronic leak detectors and dye to find those leaks. Yeah. Some peace of mind, we do talk about, anytime we use, say, a multimeter or a scope, we like to make sure that that's working before we do our test. You should be checking your leak detectors before you try to do leak detection. Infocon sells this. It's called the Tech Check, used to check leak detector. It's a controlled leak, 5 to 9 grams per year of refrigerant. Open it, turn it on, take it past the tip of your detector, and see if that detector goes off. The other down and dirty is if you have -20 washer solvent in the shop that has methanol in it, a leak detector will always trigger on methanol, on -20 washer solvent. So that's a good check if I want to see if my detector is working. Part of these standards for leak detectors is that the manufacturer will include documentation with the leak detector of yes or no if it false triggers on certain chemicals, and we can use that to our advantage. I'm going to skip this video of testing leak detectors because we are starting to run short on time. One of the components that has been added to a 1234YF system, the vast majority of 1234YF systems have these, some 134A systems have them, is an inline heat exchanger. You can see this is under the hood of a Mercedes, and we can see right here, the suction line and the liquid line come together, run pipe in a pipe, with the suction line down the middle, the liquid line on the outside, till they split to go into the evaporator. What we're doing is we're trying to take that cold refrigerant that's coming out of the evaporator core, still has capacity to pick up heat. And we're taking more heat out of the refrigerant that comes from the condenser so that we can pick up more heat in the evaporator core. We'll talk more about that in the second part of the class. The bane of the professional automotive air conditioning technician is the self-sealing can, or the small can of refrigerant. When in the beginning of 2018, when it became mandatory that you have a 609 license to purchase any container of refrigerant over 2 pounds, a change was also made to the small cans. Small cans were not outlawed. There was talk what was going to happen. The end result is we still have small cans available. But you can see the can on the left here. This is an old style small can. It's a punch top style can. So the tap for this can, when we go to use it, would take and have a pin that we would drive through this seal to release refrigerant. The problem with that is an air conditioning system's charge generally is not even multiples of a can. So you wind up with a partial can that has refrigerant in it. So if I take that can off the gauge, now all of that refrigerant is going to vent into the atmosphere. Kind of defeats the purpose of a lot of what we're trying to do. So those cans were replaced with these cans that have a resealable valve. There's a ball valve in the top of this can that when I take the tap and screw it on, instead of punching a hole, I'm opening a ball valve. If I try to use a punch top tap for this can on this can, I will most likely damage the valve and may not get any refrigerant out until I take the tap off, in which case the can will no longer be able to seal. So make sure if you are using small cans that you are using the correct tap for the kind of can that you are using. Sealant detection goes hand in hand with small cans. You know, a lot of the small.
Good luck buying small containers of 134 that doesn't have junk in it.
As Bryn said, there's a lot of junk floating around on the market, and we need to make sure that we're not recovering sealant into our equipment. The sealant has the potential not only to damage the vehicle's air conditioning system, it has the potential to damage our equipment. So this tool, it's made by Neutronics, is to detect sealant in the system. You can see there's a coupler that attaches the high side fitting of the vehicle. There's couplers available for 12, 134A, and YF. We have a brass plug. They use the little syringe, fill both sides of the brass plug with water, attach the brass plug to the coupler. The other end of the brass plug has a hose barb on it that we attach to this flow meter, attach to the high side of the system, let refrigerant start to flow, mark with the rubber band where the flow meter settles at. Walk away for 3 minutes.
I think you may have
Come
said.
back 3 minutes later and.
I think you may. I'm sorry to interrupt. I think you may have said, but I missed it. So just in case you didn't, the engine's not running. AC's not on at this point.
Correct. That's a good point, Bryn. I did neglect to mention that. We are testing, doing sealant detection and refrigerant identification with the engine off. The only caveat to that is on a cold day, it does take about 50 pounds of static pressure to make a sealant detector work. So if it's a particularly cold day and you bring a vehicle in, like say you're recovering refrigerant to do an engine job or a heater core or something like that, you may have to run the vehicle for a while to get the static pressure up enough to do a sealer test. Cool. But after we hook up, we let the flow meter settle, walk away for about 3 minutes, come back, and if flow has dropped more than 15%, the system has sealer in it and the customer is in for a world of pain. But we know that we don't want to recover that refrigerant because we don't want to contaminate our equipment. So it takes 3 minutes. It's cheap insurance for your R machine. One note on flushing components. As systems have gotten more and more efficient, the condenser passages have gotten smaller and smaller. You can see the passages at the top of this screen are 0.4 millimeter by 0.8 millimeter. I have some condenser cross sections that are even smaller than that. These are very, very difficult to flush, if not impossible. So be aware of that. If we have a compressor failure, you're probably going to have to replace the condenser on a 1234 YF vehicle that has a compressor failure. And you're also going to want to replace any hoses that have mufflers in them because the mufflers are going to have screens in them to catch any debris. So at that point, we have our first poll questions for the night. Bryn, we're going to do poll questions 1, 3, and 4.
Okay. All right. That's poll question 1 up right now. Let's see.
So what are the methods that a modern AC machine uses to achieve the correct charge accuracy? Select any answer that applies. There may be more than one answer applying. Again, guys, please answer the poll questions. None of us see who answers it. We just see the answers. We don't see the actually who made the answer. Who answered?
Anonymous. Throw them up. We got about 30% have voted so far, so we'll give it a few more seconds.
Again, guys, these poll questions, since I'm not sitting in the room in front of you, one of the things that all of us say as instructors, when we're sitting in the room in front of you and looking around, we get an idea of whether we're getting the point across that we are trying to get across. The poll questions in this type of format is your chance to tell me whether I got across the point that I was trying to get across or not.
About 60% now. Looks like Kelly had asked where. Is it not coming up on your screen, Kelly? Oh, it's not coming up. I'm not sure. Should have just popped up, I believe.
Yeah, they usually just pop.
If you've got pop-ups blocked, it may not show up.
Yeah.
Good point, Ken.
All right, well.
So it looks like it's kind of leveled out. Almost everyone got the correct answers on this one. The choices were, what does the machine do? Some choices were nothing. You should add 2 to 4 ounces of refrigerant for every charge. That's definitely not the case. That is not a best practice. The 2 that the machine does is charge compensation. Either the machine knowing how much refrigerant is in the machine and how much it needs to add, or hose compensation, meaning that after we're done charging, we're going to take that refrigerant that's in the hoses and pull it into the machine. So almost everyone got those, either one or both of those answers. So next one's number 3,
cool.
Brent.
You want 3 next?
Yeah, 3 next.
They may come in order of 1, 2, 3. Let me see.
I think at the top, before you hit start polling, you can pick which question comes up.
Another instructor said to Kelly, if you're using a tablet, the polls may not show up. It may be the same with a phone. Let's see. Okay. Okay, you said 3. There we go. There it is. You see it, Tim?
Okay. Yep, we're up. So on this one, Technician A says that all 1234 YF RRR machines must conform to the performance standards and steps defined by the SAE standards. Technician B says that all 1234 YF machines are required to identify the refrigerant purity prior to recovery. Who is correct? Technician A, Technician B, both, or neither?
Jamming through them now. Thanks.
Yep.
Thanks. Ooh, some feedback there. Some bass. All right, we have about 64. We'll give it another 10 seconds or so.
Yep. All right, so the correct answer for that question is both. So the RRR machine has to conform to J2843 or J3030, which defines the minimum performance standards and the methodology. And part of that standard, Technician B is correct. Every machine is going to require refrigerant identification, and that if the machine is not pure, it will not recover. And then question 4, Brent.
Okay, let's see. Question 4. There we are.
Okay, the standards for R134A recovery and recycling blank. Select all that apply. A, set a recovery efficiency standard, meaning how much refrigerant is recovered. Set a charge accuracy standard, and cover the purity standards for recycled refrigerant. Select all that apply.
Let's see. Last one was what, 65%? Let's see if we can beat 65%. Throw the answers up there, folks.
Yep.
Really
Again,
appreciate the participation.
Yep. Again, guys, like we said, we don't know who answers what. All we see is that people voted.
Come on. 65%, 67, yes.
There you go. You got your wish, Bryn.
Okay. Looks
right.
like we're good at 69.
Looks like we're about, yep. So the answer for that is all of the above. As I said, the 134A machine recovery, recycle, and recharge standards are about the same as the R1234YF. So it says, again, we have to recover 95% of the refrigerant, charge within a half of an ounce, and there is a standard of purity for recycled refrigerant as well as for virgin refrigerant. So with that, we can hide the polls for a while. We're done with that. We'll move on to the next section. I think this might be our last section for tonight. I'm not sure. We should make it through this. I don't know how much further we'll make it. Leak detection. Leak detection is the name of the game when it comes to air conditioning. I mean, this is the most important service that we do. You know, that refrigerant, the vehicle lost its charge, that refrigerant went somewhere. Yeah, low refrigerant charge is the leading cause of performance loss. Low refrigerant charge starves the compressor for oil. Low refrigerant charge makes the compressor run hot, shortens compressor life. That said, leak detection is not easy. You know, leak detection tends to be a very, very challenging thing. I wish I could say that there was one method for leak detection that finds every leak every time is 100% dependable. If any of you guys find it, figure it out, let me know. There are multiple ways to do leak detection, multiple ways that work sometimes don't. Leak detection is more of an art than a science. One of the possible problems is components can be very, very hard to access. You know, think about what a front-end cooling stack looks like. Not that many years ago, you could look through the grill and see the condenser. You could look down the core support to see the condenser. Now, how many cars have active grill shutters, something blocking the condenser that we don't have particularly good access anymore? The compressor might be buried. There are cars where you can't even see the lines to do leak detection. You know, cars that you can't get to an evaporator drain very easily. Cars that you can't get a blower resistor or blower motor out of to get into an HVAC case. We're also, as systems have gotten tighter and tighter, we're dealing with smaller and smaller leaks. That's why our leak detectors, you know, the two leak detectors that are on the screen that are J2791, J2913, are capable of finding a leak as small as 4 grams a year, in the hopes that we will catch a trace of refrigerant from that leak. And all of the different methods are good at finding leaks different ways. You know, there's several tools. We discussed some of them. We'll discuss them more in depth. It also involves proper techniques. I always say, and the guys tend to laugh, every leak detector has a personality. And you have to start becoming comfortable with your leak detector, figuring out what will make it false trigger. And how do I need to work with it in order to get the best out of it? For example, I have 3 leak detectors that I use in the shop. I know that 2 of them will false trigger if I bump the tip. The third one will not. So I have to be mindful of that while I'm using the detector. Some standards that govern leak detection: J1627 was the old standard for 134A for leak detectors. 2791 is the newer standard for leak detectors. J2791 leak detectors do generally work better than 1627 leak detectors. There are some old 1627 detectors that were quite good. J1628 outlines the best practices for leak detection. That standard is currently being revisited and revised. J2297 we talked about is DI, and J2913 is the leak detection standard for 1234YF. So if we're going to do leak detection, we're going to start by choosing our method. Are we going to do electronic? Are we going to use trace dye? Are we going to do vacuum decay? Heck, soap bubbles work sometimes, depending on the leak you're looking for. You can see in this picture, we're using a liquid leak detector, spraying it around the service port cap, and we can see that compressor manifold foaming. So there's a crack in the compressor manifold at that point. Are we going to do something like forming gas? Are we going to use nitrogen? Pick what method you're going to use. We're going to start by preparing the vehicle for leak detection. Part of that is evaluating the vehicle history. We want to know things like, has anything been done to this car? Is it possible this vehicle was in an accident? If the vehicle was in an accident, and I know a front end accident, and I know the front end of the car was apart, now I'm going to be starting there. I'm going to be looking at the condenser. I'm going to be looking at the fittings. Did something happen like the condenser was replaced in the accident and possibly an O-ring got rolled or pinched when the hoses were put back together? Things that happen. Did a crack in the condenser get missed? Something like that. If I know that, say, this car just had an engine replacement, I might be heading down and looking at the compressor manifold, things like that. Prepare the vehicle. So if I'm going to do electronic detection, I need to make sure that that system has refrigerant in it. If there's no refrigerant in the system, there's nothing for my leak detector to pick up. Same thing if I want to use dye, I need to make sure that that system has dye in it. If I'm going to try to do vacuum decay leak testing, possibly listening for a vacuum leak with an ultrasonic detector or something like that, I need to recover the refrigerant from the system and then pull that system into a vacuum. If I'm going to do soap bubbles, I need to, again, make sure there's something in the system to bubble. After I figure out what I'm going to do, now I have to do it. Choose my method, go find the leaks. After I find the leaks, now it's just like a drivability problem. We talk about, we set a lean code. We're going to figure out why we're lean, but then after we make the repair, we're going to go back and verify. So say I find a leak at that condenser fitting after the car's been in an accident, I replace the O-rings. Now after I put that back together, I need to do whatever test I did to find that leak and do it again to make sure I fixed the leak. In addition to making sure that I didn't create any other leaks. One big mistake a lot of guys make is you find one leak and stop looking. Make sure that even if you find a leak the first place you look, that you still go back and check the rest of the system. Part of the standard for leak detection is we can set, the detectors have multiple settings. So the sensitivity settings that are built into the tools are 4, 7, and 12 grams per year. Generally, what I like to do is you start with the highest sensitivity setting, or start with the lowest sensitivity setting, so 12 grams per year, and work my way down. The lower sensitivity I'm on, generally the least likely I am to false trigger. As you said, most of the detectors that are 2913 do meet 2791. So how an electronic leak detector works, so we said they're capable of finding very, very small leaks, and the detector will alert you to a leak with either an audible or a visual warning. You can see this detector has a light scale that, depending on how bad the leak is, it will start lighting more lights and the beeping will become faster. As I said again, know your leak detector, know what tool you are using. There is maintenance that has to be done on leak detectors. There is a filter somewhere in that leak detector to keep moisture from getting into the sensor and to keep other nasty stuff from getting into the sensor. Periodically check that filter. If it becomes contaminated, replace it. These do have a maintenance schedule from the manufacturer that they are to be replaced every so many hours. The same thing goes for the sensing element on the leak detector. The sensing tip or sensor inside needs to periodically be replaced. Never run without a filter. There is a pump inside of that leak detector. That's part of what you hear running when the detector is running. You don't want to suck something into that leak detector without a filter on the tip. Best practices for leak detection. We generally want to leak test with the engine off if we're doing electronic leak detection. One of the reasons why is if you're running the engine with the engine cooling fan running, any refrigerant that is leaking can be dispersed. The other thing is, depending on your leak detector, air movement at high speed, like from an engine cooling fan, can false trigger your leak detector. So we want a still environment, block off any drafts. I like to work in my bay with the garage door closed to make sure that the environment is as still as possible. Make sure that the component you're leak detecting is clean. If there's engine oil, if there is something else on it that can possibly false trigger the detector, clean it off. Now, when you clean it, be careful with what you're cleaning with. Almost every leak detector out there will false trigger on brake clean. Don't just spray the component down with brake clean. Anything that's got chlorine in it is going to false trigger a leak detector. It starts to look like R12 to a detector. Using a clean, dry, lint-free rag is a great way. You wipe it off, a little bit of water if you need to. Make sure that it's dry, and then go do your leak detection. The number one thing with electronic leak detection is patience. Guys tend to move too quickly. The standard says to move at 1 to 2 inches per second. To me, that's a little bit fast. You have to give the leak detector time to find the leak. Time for that refrigerant to get from the tip, where the component is, up into the sensing element and to register the leak. So we said no more than 1 to 2 inches per second. The SAE standard for J2791, J2913 is that the detector can be at 3/8 of an inch. Closer is better without touching. I generally do like to be within 1/4 of an inch. And you generally want to check both the top and the bottom. Refrigerant is heavier than air, so it will tend to fall to the bottom of the fitting that is leaking, or to the bottom of the leak. The opposite of that, if you are using forming gas for leak detection, the hydrogen in forming gas is lighter than air, so your leak will tend to be at the top of the component. If we find something, confirm it. Your test, in order for your test to be accurate, it needs to be repeatable. That means that if I find a leak, I should be able to take my leak detector away, let it clear, go back, and it trigger again. If you suspect you've got a buildup of something, hit it with shop air, clean, dry shop air, and go back. See if it false triggers again. Never blow compressed air into the tip of your leak detector. One other thing I hear a lot that I'll talk about now as far as safety is I hear a lot of guys saying, I pressurized the system with shop air to leak detect it. Never, ever put shop air into an air conditioning system. Couple of reasons. One, shop air tends to be pretty nasty. I'm sure being in Florida, Bryn, you probably have some moisture issues in your compressed air. I know as humid as it's been here in Pennsylvania, I can drain my compressor every day and my shop air is wet. We don't want to put that moisture in. We don't want to put that junk in the system. Coupled with the fact that when 134A mixes with compressed air in a pressurized environment, 134A can become explosive. So definitely have some safety issues there. So we said make sure you test the entire system. Now, evaporator leak detection can be a problem. What we want to do is run the blower on high speed to get that refrigerant moving. Turn it off. Wait at least 5 minutes for that refrigerant to start to drop to the bottom of the HVAC case. Again, patience. After you run the car, let it sit outside for a while. Let that refrigerant drop to the bottom of the case. Go do something else for a little bit. Then you want to find the lowest possible access to the HVAC box that you have. Either center floor duct. Center floor duct is one I don't particularly like. That tends to be my last resort. I like to go either through a blower resistor, through the blower motor, through the drain, something to get into the HVAC box and try to get to the evaporator core. One of the big things when you're running that blower fan is we're trying to dry the evaporator core. Moisture will generally false trigger a leak detector. So we want to make sure that there's no condensate in the evaporator core or in the drain that will give us a false positive. Again, patience. Let that refrigerant accumulate. Let it get to the tip of the leak detector. Again, this is a case generally when I'm in the summer working, I'm trying to find an evaporator leak. I've got my leak detector sitting in the case. I'm making sure I'm working in a part of the shop that I can hear it. I'm usually doing something else and listening for my leak detector to trigger. So summary of this, we're going to leak test with the engine off. Generally, you want at least 50 psi of static pressure in the system. Avoid contaminating the tip of the leak detector, and no solvents to clean components. Do a visual inspection first, whether you're looking for dye or not. Look for something obvious. If I see I've got a condenser that's bent, like the car's been in a front end impact, I'm going to go to the condenser first. Look for oil stains. Even if the system doesn't have dye in it, look for something that's heavily corroded. We're doing the mile high view at this point, looking for good places to start. We want to check all of the fittings, check every connection. Go start at a point in the refrigeration circuit and work your way back around to that point to find the leak. So you said be close to the system with the detector, moving slowly around the system. And service ports we need to test with the cap on. Remember, with the service port, the cap is the primary seal. If we find a leak, verify it. Clear the area out, go back and retest. And we talked about evaporator core testing. We said check before each use. Make sure that your probe tip is clean. Both, as we said, the bottom of the fitting, the bottom of the line is generally where you're going to see a trigger. If you're in a contaminated area, make sure to re-zero your leak detector to block out the contamination. Something like the guy in the next base just washed something down with brake clean. Your leak detector is probably going to detect that. So we want to re-zero the leak detector in order to back that out. A leak should be repeatable. If that is a true leak, I should be able to clear it, go back to it, and find the leak again. If you have something that you trigger and it's not repeatable, it's either a leak that is not significant or you may be picking something else up. We talked about dye, that if you're going to use dye, make sure it meets the standards. Do not use more dye than is recommended. This particular bottle of dye, they consider a small AC system, a system with less than 5 ounces of oil capacity, which is most of our systems. They want 1/8 of an ounce of dye. But it shouldn't be part of your standard procedure to just add dye to the system. You should only be adding dye if there is no dye. 1 dose of dye for the system is enough. In order for dye to show a leak, the system has to run. We have to circulate that refrigerant and oil in order to find that leak. If we're going to do dye, our first step with UV dye is to see if we have dye. If not, if we don't have dye, we need to add it. If we do have dye, we don't. Either check service information to see if it's a system from the factory, check service history to see if dye was previously added. Sometimes you can see that a residue on a service port, like in this picture, that would indicate that this system has had dye injected and the dye was not cleaned off of the service port. Again, know your equipment, putting the correct amount of dye in, and make sure that the light that you have works with the dye that you have. The way that dye works, as I said, dye is made up of oil and a fluorophore. The fluorophore is what physically glows. So when we take an ultraviolet light and we shine it on that dye, photons of light, photon is basically a particle of light of a certain frequency, hits that dye, excites that dye, and makes it emit a photon of light of another frequency. So we need to make sure that we're hitting that dye with a frequency that will excite it. Most of the dyes that are currently sold are made to be excited with a 405 nanometer wavelength light. A little bit lower, the light that I personally like is a 390 nanometer wavelength light, and it works well. A 450 nanometer wavelength light, which is most of the older lights that look really blue when you look at them, do not work real well with current dye. So make sure that your light works with whatever kind of dye you're using. As we said, you have to circulate the dye. Sometimes if you have an evaporator leak, either using an inspection camera with a UV tip on the end of it, you might be able to see dye on the surface of the core. You might be able to see some dye in the drain water or at the end of the drain hose. Use the light that works with your dye. Use the goggles if necessary. When it comes said about knowing your equipment, know how your eyes react to dye as well. Me personally, I have a condition in my eyes that if I put the UV goggles on, which is a UV filter, all of the ultraviolet light reflecting back into my eyes physically makes my eyes glow. All I see when I wear the goggles is green. So I have to make sure that I'm using a light that I can see the dye well enough without the goggles, or I physically can't see it. Again, once you put dye in, once you find your leak, clean it up. Clean the dye residue off of the surface. There are some limitations to dye. Dye is a great thing. If you have dye on a component, it means you have a leak. But just because there is no dye on a component doesn't mean that you don't have a leak there. Depending on where in the system the component is, it may not show dye. As I said, dye depends on the oil to circulate it. If we're in a part of the system that doesn't have a whole lot of oil circulation, like the top of a condenser, the top of an evaporator core, you may not see dye. Also, generally, low side leaks do not show dye as well as high side leaks. Think about it, a suction hose. What happens when that system is operating? That suction hose gets really cold. We have very low pressure in that component, and we have condensate buildup. So because we have low pressure in the suction line, it can often take a very, very long time for dye to show up, especially because that condensate, we have very little dye coming out to start with, and that condensate can start to dilute the dye. Visibility challenges, can we physically see the component to see if there is dye there, in addition to what I talked about, the visibility challenges, possibly with your eyes. We're going to do vacuum leak detection. The downside to vacuum leak detection is it can be hard to physically find where the leak is. It's a great idea to do the vacuum decay leak test to see if you have a leak, but you will probably have to go to another method to pinpoint what the leak is. Most AC machines will do a vacuum decay leak test. Once you pull the system into a vacuum, you'll do the leak test and let the machine monitor it. If your machine does not do a vacuum decay leak test, you can do a manual test. Pull the system into a vacuum, make sure that the system is in a deep vacuum, that all of the refrigerant and water vapor is boiled out so that it stays in a deep vacuum, isolate the system, and look for loss of vacuum. Now, if you're going to do that test, you really need a micron gauge. Micron gauges are gauges that are designed to measure very, very small amounts of vacuum. A manifold gauge set for air conditioning service is designed to measure a very large range of pressures, and they are not particularly good at measuring small vacuums. So if we want to do a vacuum decay leak test, we really need to be using a micron gauge to do it. Again, soapy water works for some leaks. Again, it depends on access. The generally accepted rule is that soap bubbles will start to form on leaks larger than 50 ounces per year. So if you're finding a leak with soap bubbles, it is probably a rather large leak. But it can be useful sometimes. If you're working in an area where your leak detector is going crazy, you've got contamination, it's hard to pinpoint where that leak is. Soap bubbles can be helpful to start to pinpoint where that leak is. My personal preference for soap solution to find leaks, I like white wall cleaner. It's what I find works the best for me. As I said, the service port caps are the primary seal. Make sure that they go back on. And when we're leak testing around the service ports, we generally want to check with the caps on. I'm going to skip this video because we are running out of time. Same thing. One thing you'll find, 1234YF vehicles, lots of the caps are tethered so they don't go missing, but not all of them. Make sure the cap gets back on. With that, I think we're just about out of time. It is 8:53. Bryn, do we have any questions from the audience that we didn't answer yet?
We did. We have a few questions, and we're going to read to you in just a moment. Lots of activity in the chat. Some of them might be questions. It's kind of hard to say. It looks like there's some advice going on in there as well. That's cool. If there is anything that you guys posted in the chat that you wanted answered, I'd encourage you to move it over the Q&A now while I answer, or have Tim answer the first three. A couple things, Tim, great job, but the leak detection stuff was really cool. I think a lot of technicians complain about electronic leak detectors, and I think the tips that you gave with making sure their stuff is up to certain today's standards. I think a lot of folks are using really old leak detectors and hoping, and assuming that they're going to get good results. And the other thing is the false positives that you mentioned. A lot of stuff under the hood gives false positives. So very cool.
Going off of what Bryn said, with leak detectors and leak detector age. Now, my shop is a high volume air conditioning shop. It is one of the things we specialize in. I replace my leak detectors every 2 years. Doing a lot of air conditioning, I find that after 2 years, that's about when they start to wear out. And you can tell a difference between a new leak detector and a couple-year-old leak detector. Lower volume shops, if your leak detector is more than 5 years old, buy a new one, would be my advice. And I think you'll be pleasantly surprised with how much better the new generation of leak detectors work than the older ones.
Yeah, and those vials that produce 3 to 9 grams a year or whatever leak, that's pretty cool. And you can also do similar stuff when you remove the service port cap. You can always kind of do that to test them as well. But like Tim said earlier, kind of like we test a voltmeter, put it on a battery, make sure it works. We want to do the same with our leak detector. But here's some questions for us. One from John. What about nitrogen for leak detection? I think you mentioned that earlier, but you want to recap?
Yeah, I mentioned nitrogen a little bit. So here's the thing with nitrogen. On the light vehicle side, there is no OEM that currently endorses nitrogen. On the heavy duty side, it's a different story. It kind of goes to where the differences in the systems, and on the heavy duty side, you're also using nitrogen to do something called the triple evacuation, where you evacuate the system, blow nitrogen one direction, blow nitrogen the other direction, and then evacuate the system again to help get moisture out. Personally, I am not a fan of nitrogen testing for light vehicles. I've seen too many systems damaged over the years using nitrogen. I've had it usually comes from guys that are commercial HVAC guys because they use nitrogen for leak detection. Most of your automotive evaporators will blow apart between 150 and 175 PSI. So if you're trying to do nitrogen testing and trying to get pressure up enough to find, say, a condenser leak, you're probably damaging the evaporator core, and you're also running the risk of damaging a compressor control valve. Most of our modern vehicles have variable displacement compressors, and we start putting that kind of pressure in the system, we can damage the compressors, the control valves inside. The other thing with it is, I can pressurize that system and see, do I have a leak? But then I've still got to find it. So to me, that kind of defeats the purpose. I know there's a leak in that system already. It lost the charge. The final thing with nitrogen goes back to what I said about with forming gas. Forming gas is 95% nitrogen. To me, that's a static test. If I've got nitrogen in the system, I can't make that system operate. It doesn't work on nitrogen. So to me, it's like using a voltmeter to test a cam sensor versus using a lab scope to test a cam sensor, testing statically versus dynamically. So, I'm not a fan of nitrogen. If you're using nitrogen and it works for you and you're having good results with it, I'm not going to tell you to change what you're doing. But that's my feelings on nitrogen.
Are heavy-duty trucks, off-road equipment, AG equipment, etc., required to label the quantity? That's from William.
That gets into some debate. I know at the SAE level and at Max, we are very much working on trying to improve some of that on the heavy-duty ag side. We know heavy-duty and ag is currently basically the wild, wild west of the air conditioning system. I don't have a good answer for you on that, other than we're working on
it. I said AG. I didn't realize that was ag. That makes sense. Kelly asks, if you evacuate a system with dye, would you need to add any dye into the system?
So good, very, very good question. If you evacuate a system with dye, do you need to add more? The answer to that is no. So one, generally when you recover refrigerant from a system, you shouldn't be removing a lot of oil. You generally remove very little. If you're removing a lot of oil with your triple R machine, you probably had a system that was overcharged with oil to start with. The way that dye is put in on the assembly line, we tend to think we introduce dye as a quantity mixed with PAG oil. The OEM dye is generally a dry powder that is put into the accumulator or receiver desiccant, and it will keep giving off dye until such a time as there's nothing left. The only time that you would have to completely replace the dye is if you flush all of the oil out of the system. So if say we have a catastrophic compressor failure and I'm replacing the condenser, I'm replacing the accumulator, the dryer, and I'm flushing what's left, and I have a clean dry system to start with, then I would want to make up some of the oil volume with dye.
All right. When vacuuming a system, is it better to vacuum for more than the generic 10 minutes with the machine?
Well, best practice, we recommend, the SAE practice recommends at least 30 minutes of vacuum. We tend to recommend at least 45 minutes on a single evaporator system, at least an hour on a dual evaporator system. There is no such thing as leaving the system evacuate for too long. You're not going to hurt anything by letting it evacuate for a long period of time. I tend to, like, if I'm doing, say, an evaporator job, one of the things that I do is as soon as I bolt the HVAC box back up and close the system, I turn my vacuum pump on. Because I want to see if I can do pull into a vacuum. I'm going to do my vacuum decay leak test before I put the dash back in. Because if I've got to backtrack 20 minutes to pull that HVAC box back out, I want to know now. 20 minutes is going to annoy me. 3 hours is really going to annoy me. But I'll generally start it, evacuate it. Once I'm settled into a vacuum and I've done a vacuum decay test, then I'll usually just leave it run until I put the dash back in and I'm ready to go. So you're not going to hurt anything by leaving it evacuate longer.
What are your thoughts on refrigerant with dye in it? That's Carl.
What are my thoughts on refrigerant with dye in it? One of the challenges with refrigerant with dye is you don't know how much dye you're putting into the system. That refrigerant with dye in it basically is refrigerant that has oil mixed in it. In order to charge that, you have to charge as a liquid. You can't charge that as a vapor. You're not going to put any of the dye in it. The dye is going to settle to the bottom of the cylinder. Personally, I would charge, if I need to add dye to a system, I would add the dye of my choice first and then add the refrigerant on top of it. I'm not a fan of refrigerant with dye.
All right, looks like we're caught up on questions.
Okay.
Okay. Well, with that, guys, I hope you enjoyed what we discussed tonight. We'll pick back up here on Thursday night with system performance testing and temperature testing.
Yeah.